Now I welcome you all. In this class, we are going to discuss one numerical problem which is based on the concept of equilibrium conditions. Okay, and that support reaction we have to find in this problem that by using the equilibrium conditions. So the problem is on the screen that find the reaction at support A and B in the beam AB as shown in the figure. So let's see that you have one beam is given of having length is 6 meter. The total length of the beam is 6 meter. 1 plus 2 3, 3 plus 2 and 5 5.5 and 0.5 is the 6. Okay, so we have to find out the reaction at the support A and B. Okay, now what are the forces is given? Let's discuss that. First of all, you can see one horizontal reaction. You can say it is acting at a support A towards rightward direction. Okay, and that reaction vertically upward, which we have to find. And then the reaction at B, and this reaction is not exactly vertical, it is inclined with an inclination of 60 degree, right? And also we have a three forces is given. 60 kilonewton, which is inclined with a 60 degree, and 80 kilonewton, which is inclined at 75 degrees, and 50 kilonewton, which is inclined at 60 degree, right? Okay, so first of all, we have a three equilibrium condition, that is summation of fx is equal to 0, summation of fy is equal to 0, and summation of m is equal to 0. Okay, now so we will use first all three condition we'll use to get that reaction at A and B. First we'll impose the summation of m is equal to 0. Means what? Any point we have to choose. About that point we need to find the moment about these forces, and their sum should be equal to 0, right? So let's say that I am considering the point A about which we are finding the moment. So how many forces is there? That one horizontal reaction, vertical reaction at RA, this 60, 80 kilonewtons, 50 kilonewton, and the reaction at B. So reaction at B is inclined, it means that we'll get their component, and these three forces are also inclined, which means we'll get their component, right? So because of these forces, whatever the moment we'll get, their sum we need to find. So first of all, I have chosen the point A. So you can say, yes, so you can say that moment about A. So is this pen here? So summation of MA is equal to 0, right? Now, so let us see that how many forces is there. So first we can't take this reaction RA to get the moment. Why? Because we are finding the moment about A only. Okay, so if you take this vertical forces, we don't have any distance between the force and that point where we are finding the moment, right? Second, if you want to take this horizontal reaction, so you can't take. Why? Because the beam is horizontal and the force is also acting horizontal. So horizontal force and horizontal distance does not generate any moment. Okay, now the 60 kilonewton is inclined. It means that we'll get that component, that is vertical component, okay, and the horizontal component. So which force you'll take? Again, if you want to take the horizontal force, there is no perpendicular distance. Why? Because beam is kept horizontal, right? So you need to take the vertical component, so the distance will be 1 meter. For this also you have two component, that is one vertical component and the horizontal component will be like this. This arrow is like this, so it will goes left. In this case the arrow is like this, so horizontal force will goes towards the right. This is also you need to take their component, that is vertical component and the horizontal component, right? When we discuss this reaction, so the reaction will be RB vertically up, and this is the horizontal towards left. So it's very simple. Now you can impose the relation. Moment is what? Force into perpendicular distance. So its vertical component is what? 60 sine 60 its vertical component is 80 sine 75, its vertical component is 50 sine 60. For this force the distance is 1 meter, for this force the distance is 2 plus 1 3, and for this force the distance is 3 plus 2.5 5.5, and for this reaction the total distance is 6 meter. Alright, now, and one more thing, that please, that when you take this vertical component and the distance will be like this, is it or not? So it means that the force you will apply horizontally, vertically down. So how the rotation will take place? The rotation will take place, that is like this, means clockwise. For this force that is it is like this, so this will also clockwise, right now. But for this for this one will also clockwise, right? Means these three forces, that forces is acting vertically downward, so your rotation will be clockwise, but for the reaction it will be anti-clockwise, right? So if you know the sign convention that clockwise moment is negative and anti-clockwise moment is the positive, that we have discussed in the previous classes, right? So you can go through with the previous videos, right? Now, so first of all we can let's take that RB itself. So RB, its vertical component is RB sine 60, okay, and the distance is 6 meter. It's positive minus this 50, just wait, something is vibrating now, 50 sine 60 into 5.5, this distance, minus we have taken, why? Because it is the clockwise moment, right? And this is your 80 sine 75 into, this is the 3, right? Okay, continuation, minus 60 sine this is your 60 degree into 1 meter is equal to 0, right? 1 2 3 4 forces we have taken, these two forces you won't take, we have, you know already, right? So now when you equate this, so this value you can put in your calci and get that value. So RB is equal to what? RB is equal to this whole, I'll show you that when you bring these three terms towards this side it will become positive, right? So it is RB is equal to 50 sine 60 into 5.5 plus 80 sine 75 into 3 plus 60 sine 60 into 1 over this term, right? That sine 60 into 6 will come in the denominator, that is sine 60 degree into 6. So RB value will got, sorry, this is guys, now it's fine. Okay, so RB is equal to what? You can calculate and get that value, that is 100.56 kilo Newton. So RB value we calculated, that first vertical reaction we got at RB, right? Now then we have to see the to get the RA value, what we need to do, that horizontal force and vertical force we have to get, right? So first of all I am writing the summation of this is summation of H is equal to 0, right? So summation of H is equal to 0 means what? That summation of H is equal to 0 means all the horizontal forces. So let's come back to the question, that is this horizontal reaction is right, its horizontal component is going right, you can see this, and this is the left, it will be negative. For 80 kilonewton the horizontal component is negative, and this 50 kilonewton is also it's a positive, and RB also you have to take, why? Because it is the force now, right? So you will get this, it is in the negative direction, right? So put this value, it's so simple, you can see this is HA positive and plus 60 cos 60 degree minus 80 cos 75. Why? Because 80 is, the arrow is like this, so it is going towards left, right? And plus 50 cos 60 and minus RB cos 60 degree, right? That should be equal to 0. So now all the values you have, you already calculated the RB value. From here you can put, and HA is equal to what? This whole term except H will come to this side, right? So positive will become negative and negative will become positive. That you know, it's very simple mathematics, right? So HA is equal to, we'll get after simplification, 15.7 kilonewton. Okay, now yes, so the horizontal force at A we got. Now we need to get the vertical force at A. So for vertical force, you can say that here itself, just you can slide, summation of V is equal to 0. Let's come back to the question. Summation V is equal to 0 means what? That is vertical force on this support A, these vertical component because of 60 kilonewton, 80 kilonewton, 50 kilonewton, as well as the RB also. So let's do that. Summation V is equal to, you can say the VA, that vertical force at A, right? And minus, these are positive because at A and B the reaction will going upward, but those forces is downward direction, vertically downward direction, so these all will be negative. So you can simply put 60 sine 60 minus 80 sine 75 and minus 50 sine 60, and one more force is there which is because of the reaction, plus RB sine 60 degree, right? That is equal to 0, right? So this is equal to 0, right? Now, so now then what you need to do, that you have to see that except VA, all the things will come to that this side, right side. So negative will become positive and positive will become negative. RB value you have 100.56, you put and get that. So VA is equal to, you can calculate this, 85.44 kilonewton. Always I told you that whatever the value I am calculating, and you may cross check, right? Why? Because there is a error can come, we are the human, right? So now the question is not done yet. We have to put this value into the resultant formulas, right? So just hold on for a sec. Yes, sorry. So these formula VA and HA values we got now. So you can see here, that is, yes, so you know that RA is equal to what? RA is equal to summation root over of summation of HA square plus summation of VA square. Summation of HA and VA is that is HA and VA itself, right? So root over of HA is what you got, that is here itself, 15.7, and VA is 85.44. So 15.7 whole square plus 85.44 whole square. You can substitute and get the answer. So your RA, let me check that it is, yes, 85.4. So RA you'll get that 86.87 kilonewton, right? And so this is your answer, that RA is equal to 86.87 kilonewton, and RB is, we already calculated summation by using moment, some 100.56 kilonewton, right? So this is how we can get the support reaction at any in any beam, right, by using the equilibrium condition. So this is all about this class. In the next video we are going to start the new concept, that is the center of gravity, right? So please like, comment, subscribe and share. Thank you.